Welcome to Lesson 2, Learn C Programming on the Raspberry Pi. In lesson number 1, I went over the 3 different models of the Raspberry Pi, starting with the Model A, which I have here. Next was the Model B+. And the third one I showed you was the Model 3. I have here a Model 3 which has a micro SD card inside. Take it out. And I mentioned that in order to get your Raspberry Pi running, you have to download and install an operating system. Now I use Raspbian, so I'll show you what I did to get that. Bring up a browser and I go to raspberrypi.org. Okay, that's raspberrypi.org, and I go to downloads, and you can see there are a lot of different images for the Raspberry Pi. What's interesting is there's even a Windows 10 version available. I don't know how useful that is, but it is there. And I prefer to use Raspbian. So I would click on Raspbian, and then you can see that there are 2 versions of Raspbian called Jessie with the desktop or just Jessie Lite. The difference is, of course, is the Lite version is stripped down, doesn't have all of the software that the full version with the desktop does. So I would download this version here. It's going to be a bigger file. And what you do once you download it, you unzip it, and you're left with an image file. And that image file then has to be copied onto your micro SD card or onto your just regular size SD card here, and once you copy that on, then you can take the micro SD card and place it into your SD card slot, and your Pi is then ready to go. Okay, so but in my case I'm using a Raspberry Pi Model A, which is the original Raspberry Pi, and in fact it's the lowest power Raspberry Pi, but it seems to work quite well for these lessons I'm preparing. So the first thing I'm going to do is power up this Raspberry Pi. I'm going to hit the power switch, and you'll notice the light comes on, starts flashing. Hopefully there it goes. And once again I want to explain that this Raspberry Pi, I'm running it as a headless Raspberry Pi. In other words, there is no HDMI monitor connected here, and there is no keyboard or mouse connected to the USB. So the only access I have to this Pi is by going through the network. Now let me show you my network setup here. I have a diagram I made up for that, so you can see. Just close these windows. You can see my home system basically is I have a desktop PC here running Fedora Linux. My desktop PC has a Intel i7 CPU with 32 gigs of RAM and a 2 terabyte hard drive, so it's quite a powerful PC. And I'm using a 39-inch 4K monitor. That's what I'm recording for these lessons. And of course my PC is connected to my home router, and my router is connected to my modem, and that takes me to the outside world. Well, the router also connects to this small Raspberry Pi I have here. Okay? So one thing I can do is I could I can then use SSH to connect to the Pi. I remember the IP address was 208 on my network, so that's fine. If you're wondering what these options are to secure shell, the -C says compress, which means all data is compressed to and from. It gives it a little speed up factor for data transmission and receiving. And the X is for the X protocol, which allows me to run Windows type programs on the Pi even though I'm not connected with an HDMI monitor. Okay, so let me connect to the Pi. Remember the password, the default password for Raspbian is Raspberry. Okay, so now I'm on the Pi. Last week I created a directory called lessons, and inside I made a directory called lesson01, and you can see I have that example C program that was one of the first programs we ran here. Okay, what I'll do now is I'll make another directory, lesson-02. So now I have two directories, and in today's examples, rather, I will put into lesson-02 directory. Now, just before we start with some examples, I want to show you what your desktop would look like if you weren't running headless. In other words, if you didn't have this configuration, instead you were using HDMI monitor and a keyboard and mouse. If you were using those, then this is what your desktop would look like. And I'll use a program called Virtual Network Computer. I'll just do a search for what I was testing. Oh. Okay, so if you look at this command number 31, I start the VNC server with geometry at high def HD, which is 1920 by 1080. Okay, let's start that. Now, you don't have to download this VNC server if you installed Raspbian, because VNC server comes pre-installed with Raspbian, so you can just use it. So it says here my desktop is really on window number 1. The default window is number 0. So what I can do now is I can connect to that using VNC, I think is it client? Let me do a check on that. History. VNC viewer. Go command number 32 here shows how you can connect to that desktop. So I'll type in VNC viewer and I will connect to desktop number 1:1, like this. Now this is on the Pi or on the Raspbian that I'm running here on the Model A. You'll see that it's a little bit slow, but let me first type in my password, which is Raspberry. Okay, and then it says connecting to that desktop, and there's the desktop comes up, but as you'll see, it's very sluggish. If I was running this on a Pi 3 with a high-speed PC card or micro card, then it would be a lot quicker. Okay. But anyway, what I wanted to show you was if you were connected with a monitor here and with a USB keyboard and mouse, then this is what you would get when you start up. In fact, you could even go bring up a terminal here. There it is, and you can do some commands like that. So you don't have to run your Raspberry Pi headless as I am. I just prefer it that way. But you can run your Raspberry Pi just like you run any other PC. Just plug in a HDMI monitor or your television and plug in a keyboard and a mouse, and away you go. If you have a network, that's fine too, but it's not really necessary so far. Okay. The other thing is, if you want to use the development tool that I use, you could click up here on that little raspberry and you go to programming, and you can see the Genie Programmer's Editor, which is what I use. So I'll start that up. Again, it's a little bit slow, but it should come up. There it is. And you can see the last example I was doing. In fact, you could change it to my, let's call this integer value of x is this. I could then save it here, and you can see it's down here, it says it's saved. I could then build it, and that does a compilation in the link with the GCC command, compiled successfully, and then I could even execute it. And there's the execution window, and you can see my integer value of x is 3. I can say return to continue. So you could do all of your work just using the Pi connected to your television with a keyboard and mouse attached. You don't have to run headless. Anyway, I'm going to stop all this and go back to just running the headless system. So I'll close this, and now I'm back doing this. Okay, so what's next? Okay, what's next is I would like to show you a book available. Oops, that's not what I wanted. Let me go to here. I want to show you a book that's available for free. It's licensed under the Creative Commons. This is a book on C programming. It's called Foundations of Programming Using C, and it's by Evan Weaver, who is a professor at the School of Computer Studies, Seneca College here in Toronto. This book is available as a PDF. So if you want to download it, all you have to do is do a search on Google for Foundations of Programming Using C by Evan Weaver, and you should be able to find a copy of it somewhere, and you can download and you can use it. It basically contains 8 chapters: Introduction, Basic Computations, Basic Logic, Modularity, Addresses, Pointers, Filling in the Gaps, Arrays, Files. It contains, really, it gives you a very, very good foundation of the C language. Now, it's not 100% complete. There are pieces that are not covered, but it does give you a really, really good introduction to the C programming language. On the other hand, if you do a search or a Google search for other books on C, you will probably find hundreds, maybe thousands of them. Many would be free. Many of them could be just e-books, which would be very cheap. And some would be softcover books, and some would be hardcover books. So your choice for a book is almost infinite. But I really recommend downloading a book or buying a book, and when you have some spare time, just start reading. Start at chapter 1 and just start reading. If you get stuck, if you don't understand some part of the book, don't give up. Just move on past it to the next chapter or the next paragraph, and you'll find out that in the future, what you didn't understand 2-3 weeks ago will all of a sudden come to light, and you will understand it. So yes, by all means, get yourself a book. Okay, so here we are with starting lesson 2, and what I'd like to do is I made a directory called lesson02, so I'm going to start with some examples, and I'm going to save them in lesson02. So I'm going to change directory to lesson02, and I'm going to start up Genie. And again, since I'm running headless, I don't want to lose control of my terminal, so I will run it in the background using that ampersand command at the end of my line. Okay, so Genie comes up, and there is the pardon me, example number 1, EX1 we did last day. In fact, you can even see the change I made today. Okay, so I'm just going to take that off of my screen here, and I would like to just create a new file here. Okay, let me close this window here, minimize it, so I'll just have this on board. So let's start with a little more advanced C here, moving forward. I want to talk about data that C uses. And generally, very generally, C uses 3 kinds of data. Simple integers, which are whole numbers, like 1, 2, 3, 4, or negative numbers, -1, -2, -3. The second data type that C uses is called floating point numbers, which are real numbers, decimal numbers. For example, 10.3, 10.125, -7.6. These are called float numbers or floating point numbers. And the third data type that I want to talk about are characters. For example, the letter A is a character, or the letter B, or capital A is different from lowercase a. So let's write a program just to kind of give you a look at these 3 different data types. So I'll add a comment in now. These comments in C, or block comments in C, start with a /*, and they end with */. So this demonstrates C data types. Okay, so this line number 2 is just a comment. It's completely ignored by the compiler, and it doesn't affect your program one way or another. It's just for a human being to understand what the program is all about. So remember that in C is made up of functions, and every C program should have one function called main, M-A-I-N. And main is really the starting point of your program. The other thing that's important to note is that uppercase and lowercase are important in C, and that is that they are different. For example, if I said int I equals 3, I have declared an integer I equals 3. I could also say int I equals 4, and these are two different variables. Small I, or lowercase I, has a value 3, and uppercase I has a value 4. Of course, if I wanted to, I could have put them both on the same line like this. Put a comma here and then say I equals 4. So it's the same thing. They're both integers. One is lowercase I, one is uppercase I. Of course, they don't have to be called I. You could, any integer you want. You could say, for example, age equals 22. So that is probably a lot more meaningful than just the letter I. Okay, so that's the first type of data you can have, which is just an integer, and you use the keyword int to declare. Okay, and what I'm going to do is, in order to get some color into this, I'm going to just save this program here. Oops. I'm just going to save it here. File, save as, and I want to save it inside, where do I go? Lessons and lesson 2. Okay, and I'm going to call this one ex2.c. Okay, so I have an integer declared. Now I'm going to make a float declared. Pay equals, because floats are fractional numbers, they have decimal points. I can say pay equals, let's say you're making a minimum wage of $12.50. That's your pay. And the last data type we're going to talk about today is character. And that just represents one character. So I could call it, for example, let's call it pay underscore pay grade is equal to, quote, let's say level D. I'm trying to make these names have some meaning for you. So the integer age is 22. The float pay is your pay. Let's say it's $12.50 an hour. And the pay grade is a single character, in this case D, that tells what level of pay you're at. So for example, a pay grade of A might represent the highest pay, the highest hourly pay, for example, something like that. Okay, so let's do some manipulation with these and see what happens. Let's say, first of all, we'll just print them all out. Okay, we'll use printf. The F stands for format, which means I want to format the way the output's going to look on the screen. So printf and I'll say my age is %D. A new line, quote, comma, age. And I want to print F my pay is %F /N, quote, comma, pay my pay is %C for character /N, quote, comma, PAY underscore GRA pay grade. Okay. So if we look at these three formatted print statements, printf means print formatted. It says my age is, I want to print it out as a decimal number, like 1, 2, 3, 4, 5, or -1, -2, a whole number. I want to print the payout as a fractional number, a floating point number. And I want to print my grade out as a character. And every time I print one of these out, I want to skip a line, basically go to the next line. So I want to have 3 different lines of output. So let me save this guy here. And what I'll do is I'll build it, see how it works, and then I will execute it. And you can see my age is 22, my pay is 12.5000. You notice it puts, there's a default number of decimal points it puts, and my pay grade is the letter D. Okay, press return to continue. Now one interesting thing is, let's take the age and we will divide it by 2. Well, no, divide it by 3. So if we divide the age by 3, we should get 7 1/3. If we divide the pay by 3, well, we should get 4 point something or other. Anyway, let's save this and run it just to see what happens. I will build it again, and then I will execute. And look what we get. The interesting thing here is you'll see that when I divide an integer 22 by 3, it comes out as 7. And the reason is because an integer divided by an integer will give you an integer no matter what. So let's say 3 divided by 2 will give you a 1. But if you have a floating point number like pay and you divide it by 3, you get the correct decimals. So pay divided by 3 is 4.166667, which is correct. Whereas age divided by 3 is not the correct answer, but it's what C gives you when you're working with integers. When you're working with integers, the answer is always going to be an integer. When you're working with floats, the answer is always going to be a float. And of course, with a character, you don't really divide it because it's not really considered to be numeric. Okay. So let's move on now to example number, or another example. I'll start here with a new file, and I'll call this one example number 3. Actually, we'll call this one this is an example, convert inches to centimeters. So let's say float inches equals, let's say 12 inches. Float, I'll say 12.0. And then FL float centimeters. Well, I don't know what the answer is, but what I'll do is I'll work it out. Printf, and I'll say percent %f inches is percent %f centimeters, comma. So the first percent %f will be how many inches I have. Let me make this window a little bit longer. Inches. And the second percent %f will be how many centimeters. Inches divided by 2.54. A little bigger window here. And I will save this as and I'll go into lesson 2 and I'll save this as example 3.c. So if you look closely at this program, you'll notice that I have two floats. The first one is called inches, second one is called centimeters. And I want to convert from inches to centimeters. I have to divide the inches by 2.54. So let's try running this guy. Build. Oops. What's wrong with this? CENTI. Oh, actually, I don't even. It's telling me here that this centimeters is not even being used. So why don't I use that? I'll put centimeters is equal to inches divided by 2.54, and then instead of doing the division here, I've already done it. I'll say centimeters. So let me save this guy and I will build it again, and this time it compiled successfully. So I will now execute, and it says 12 inches is 4.72 centimeters, which is absolutely incorrect. So let's fix our program. Instead of dividing by 2.54, we have to multiply by 2.54. Save. build, and execute. And now our answer is 12 inches is about 30.5, almost 30.5 centimeters. So you notice when you're programming, you write some code, you test it. If it's incorrect, you fix it. You compile it again, you run it again. If it's still wrong, you correct it, and you keep going around and around in this programmer's loop until your program is working properly. Okay. Now, there's no reason in the world why I had to call these variables by such long names. I could have instead just called it I, and I could have just called it C for centimeter, and then I could have just said this, so it would probably save me a lot of typing, but I could have just as easily done this, and I could have got the same results. Okay, so save it, build it, and execute. And there you have it. Okay, so that's probably good enough for lesson 1, or lesson 2 rather. I think it's time now to give you some homework. And my homework would be that if you have purchased a book, or if you downloaded a book, I think that you should probably read maybe the first 5 or 10 pages for homework. Also, if you haven't got a Raspberry Pi yet, get yourself a Pi, get yourself an SD card, download Raspbian, put it on the card, plug your Raspberry Pi into a monitor and keyboard, plug your SD card into your Pi, power up, and away you go. Okay, so thank you for watching lesson number 2, and stay tuned. We'll be working on lesson number 3 shortly.